Hello everyone, welcome to Mayur Programming Club. Today we will be solving another daily LeetCode problem, and the problem's name is design a stack with increment operation. Okay, so the problem statement goes like this. You have to design a stack that supports the increment operation on its elements. Okay, and the implementation or the design of the stack will be as follows. There will be a class called custom stack whose instances will be the desired stack that we are wanting with the increment operation. Okay, so the constructor of this particular custom stack class will be having one input parameter of max size that will be indicating the maximum size of the stack that can be allowed. Okay, or the maximum number of elements. Other way of saying it is the maximum number of elements allowed in the stack. Okay, then comes the push function in the class. Okay, custom stack, and its return type will be a void, and it will be adding uh, having a parameter whose which will be added on the top of the stack. Okay, which will be indicating the value that should be added on the top of the stack. Okay, and this addition is to be only done if you have not reached your maximum size limit. Okay, which was earlier described. Okay, and then there will be a pop function. If there are some entries in the stack, then you will remove the top of the stack and return that. Otherwise, if the stack is empty, then this function will be returning -1, and there will be no parameters for this one. Okay, and then comes the increment function. For the increment function, see, the return type will be void, and there will be two parameters that will be passed to this function. The first one will be the k basically is the number of elements starting from the bottom of the stack, uh, whose values you have to increase by this much, this second equal to the second parameter. Okay, so consider this example. If there are some values like a, b and c, and k is given to be 2, so from for the bottom two values, and let's say value is given to be x, or let's say 1. Okay, so you have to increase their value by 1 for the bottom two values. Okay, so the increments the bottom k elements of the stack by this particular value. Okay, and if there are less than k elements in the stack, then increment all the elements in the stack. Okay, so it might be a possibility that this particular k will be greater than the current size of the stack. Okay, so it might be a possibility that k would have been, let's say, 4. Okay, here only 3 entries are there, but k is definitely larger than that. So we, in that case, we will increment all the entries. Okay, by the value by this much. Okay, so this is what the problem statement is saying till here. And then it's that is all. You have to implement this class, and before thinking of an approach, let's have a quick look at the constraints also. So according to the constraints, see the maximum size of the stack, and that x and k will be of order 1000. Okay, and values, basically x is the value that we are pushing. Okay, so this is x. Okay, and k is the number of stack entries from the bottom on which we are applying the increment operation. Okay, so their order will be of order 1000, and each value, that amount of increment that we will be making to k entries, bottom k entries, will be of order 100. Okay, and at most 1000 calls will be made to each of these methods, increment, push and pop, separately. Okay, so let's try to think of an approach. So a very straightforward approach that came to my mind is, see, after reading this particular statement that the stack is having a fixed size or the maximum allowed size, then I straight away think of the array. An array will be good data structure to use, because see, it will give us two things: fast access, okay, and since it is a fixed size thing, so it's it will be pretty easy to manipulate it. So how we will be manipulating this array while treating it as a stack? So see, we will be using, let's say this is a array, okay, so we will be using one variable, and first of all, before uh, naming the variable, let's mark the indices of the array. Okay, let's say there are, the max size is somewhere around 5. Okay, so this max size array will be there, okay, and these entries will be there. And so you will, what you will be doing here is, you will be having a pointer, or let's say, let's call this insertion pointer, and this will be pointing to the first index which is vacant. Okay, and we will be doing insertions like this. Okay, and this side will be treated as the top of your stack. Okay, and this particular side will be treated as the bottom of your stack. Okay, so then the whole things becomes very easy. So see, if you have to push something, then first of all you should be checking. So there will be another variable initialized. Let's call this max capacity. Okay, so max capacity will be equal to this maximum size, so 5. Okay, and insertion pointer will be starting from the 0th index, saying that we haven't inserted anything. So in case of push operation, you have to push a value x if you have not exhausted the limit. Okay, so let's say I wanted to push 3. Okay, so then you will seeing what index the insertion pointer is pointing to. You will do the insertion at that particular index, and next time you will increment the insertion pointer to point to the next vacant available slot, or you can say. Okay, so now this time it will be pointing to 1. So next time the insertion have to be done, it will be done here. Okay, so the push logic will work like this. And as far as this pop operation is being concerned, okay, so you have to return something here. So see, basically what you will be doing here is, you will be seeing at which index the insertion pointer is currently at, and you will take one step back. So since it is pointing to the vacant position, so one step back, and then you will see what is the value there, and that will be the top of your stack. Okay, so, and that you will be returning, like here it was 3. If let's say the stack would have been empty, and this insertion pointer would have been pointing to the 0th index, then we would have been saying that, okay, there is no entry in the stack as at present, so that's why you can safely return -1 in that case. Okay, so in this particular case, you should be returning -1, saying that the stack is empty and there are no values to pop. Okay, so these are two functions, and let's see what are the functions that we have to implement. Okay, these two are done, and basically constructor is the one that we can use to initialize this array. Okay, and basically tell what the size of the array would be, and then the only function that is remaining is this increment function, and this is the whole logic of designing this particular stack, because we are more interested in this increment operation. Okay, so this operation we are interested in, so let's implement that particular function. Okay, so increment inc, it is having two parameters, k and value. Okay, so see, let's say the k, there are some values. Okay, let's say a b c, and your insertion pointer will be in this case pointing to this particular one. Okay, so see, let's say the k is 2. Okay, and the value that we are looking to increment the bottom k elements in the stack is, let's say, 100. Okay, so what you will be doing is you will be basically having one another pointer, let's call this index, and it will be starting from the bottom, so 0th index, and going up till k reaches 0. So you will be basically running a loop and something like this. Let me write it more clearly on the side. So something like this you will be doing. Okay, and you should be adding another condition in which let's say the k is greater than the number of entries currently, so this index should be less than the insertion pointer. Basically, otherwise if you reach equal to the insertion pointer, then you will come to a vacant slot, or most probably the insertion pointer will be pointing to the capacity, or max capacity also. This can also be a case. So these two checks should be there. You are exhausting k values, so basically entry adding the entries, adding 100 to the entries one by one. So at this particular point your k will be reaching 0, so you will stop there, and basically the addition will be performed. Okay, so this is the whole logic, and let's have a quick look at the implementation also, then we will discuss the complexities of this approach. Okay, so let me bring the code to the board, and let's take a fresh slide for that. Let's remove this part, it is of no use. Basically it's to tell you how your class will be initialized, made instance of, and how it will be utilized. So this is the implementation. I hope it's visible enough for you. So what we will be doing here is, let's discuss that step by step. So this is the array that we will be doing insertion in, and initially I have set it to null. Then we will be initializing this array to its desired size, which is equal to the maximum size. Okay, and in the constructor, and see, one we will be having couple of variables. These variables will be the max size variable and the current size. Current size is nothing but that insertion pointer that we were talking about. Okay, so you can see that this is the insertion pointer, and max size will be, you can say, maximum capacity. Okay, so once you have initialized max size and the array that we will be treating as a stack, then you will be basically, you know, and you can also do the initialization of these two here also, this current size also in the constructor if you want. So anyways, let's discuss the post function. So if you are having some vacant slots left, then obviously do the insertion and increment your insertion pointer or the current size. Okay, and then in case of pop operation, see, if the current size or the insertion pointer is pointing to the 0 index, then you will be saying that there are no entries and you will be returning -1. Else you will take one step back, just like we were doing here. Take one step back. Okay, so and then see what is at that particular index, and return, you have to return that basically. But before returning that, decrement your current size also, saying that this entry is gone, and we next time we will be looking for the top of the stack, which will now be updated because of removal of a particular entry. Okay, so this is for that. and then you will be returning the item that you removed, basically. Okay, and this is to simulate the removal. And then the increment function, so running k times, and there might be a scenario as mentioned in the problem statement that the number of elements might be less than k. So this is for tackling that kind of scenarios. And then starting from the bottom, so 0th index, since we were treating this side to be the bottom. Okay, this particular side. So that's why, adding values from bottom to up. Okay, and doing it k times only. Then that is all, and let's discuss the complexities of these functions one by one. So see, time complexity wise, let's discuss them. So here, this particular one is order of 1. Okay, constant, and this one is also constant. Okay, and then the whole focus was on to implement this particular functionality. So this will be running k times, basically whatever is your k value, that will be running up to that, or you can say minimum of k, or you can say current size. Okay, whichever is minimum. There might be a scenario in which k can be greater than the current size, the number of elements in the stack. So that is to take into that account, that into account. And yeah, this will be the complexities. And as far as the space complexity is being concerned, see, since we are using a fixed size data structure like array, so space complexity wise it will be order of max size. Okay, so these will be the complexities. If you are still having any kind of doubts or any queries in general, then you can ask them in the comment section. And I really hope this solution walkthrough added some value to your journey of honing your DSS skills, and keep solving more and more problems. And I will be seeing you in the next video. Thank you for watching.